we are always short of time. We move on to the next class, which is the phenamates or the anthranilic acid derivatives. And again, I would want us to look at the mefenamic acid, anthranilic acid derivative, and I'm sorry, these things are not really arranged in very good order. Mefenamic acid. Go to page 13 if you have arranged yours in the order I sent to you. So page 13, or at least look for the page which has oxaprozine at the top. Then again, the general structures, and you have the non-steroidal anti-inflammatory general structure, and you can see that general structure being converted to the anthranilic acid, whereby it retains, you can see that carboxylic acid, it retains its carboxylic acid group, but it has an extra NH2 group, and that's what we call anthranilic acid. Anthranilic acid is actually aminobenzoic acid. Aminobenzoic acid is anthranilic acid, and then the anthranilic acid is now derivatized on the amino group. A second aromatic group is attached to the amino group, and once that second aromatic group then that's where you get the general anthranilic structure. And you can see there is an R on the second ring, because you will find that for activity of the anthranilic acid derivatives, you do require the second ring also to be substituted. You require substitution of the second ring, and therefore, if you look at the examples that we have mefenamic acid there, and you can see it obeys the structure, carboxylic acid, the amino group is substituted with a second aromatic group or hydrophobic group, which is also substituted with 2' to 3' methyl group. So it's a 2' 3' dimethyl anthranilic acid derivative. Then if you look at macrophenamic acid, kindly note macrophenamic acid, this has chloro group, 2 chloro group at both other positions, 2' and 6' positions, you have a chloro group, and at position 3' you have a methyl group. That is macrophenamic acid. 2' and 6' having chloro group, but 3' having a methyl group. Then if you look, the dichlorphenamic acid, that is different. It's not amongst this. You can see that is an acetic acid derivative. So the one which is not there is flufenamic acid. Flufenamic acid, again, the structure will be the same up to the second benzene ring or phenyl ring, and at position 3', put a trifluoromethyl group. At position 3', trifluoromethyl group. A trifluoromethyl group is CF3 at position 3'. That is what makes flufenamic acid. So we have examples of mefenamic acid, macrophenamic acid, and flufenamic acid. When we look at this structure, just by looking at them, and I hope we are together, let us look at their substituents. Mefenamic acid has a substituent at 2', 3'. 2', 3'. Macrophenamic acid has a substituent at 2', 6'. The other one also has a substituent at 3'. It was actually, you have one single substituent. If it is at position 3', like the trifluoromethyl group, it brings maximum activity in that molecule. So a substituent, a single substituent at 3' gives maximum activity. Methyl groups at position 2', 3' were also found to give good activity. But for chloro group, so chloro group, where the chloro groups, if you look at the macrophenamic acid, you find it has chloro groups at 2', 6', and then another methyl groups at 3'. So you can see it still satisfies the 2', 3' substituent, but it has an extra chloro group at position number 6'. Those two ortho, the chloro group at 2', chloro group at 6', you can say those are two ortho in the second ring. Those two ortho chloro groups are very important for maximum or optimal activity, because they bring out the same kind of steric hydrons we had talked about. They introduce steric hydrons and make sure that these two rings are completely out of planarity. Because of these two chloro groups, remember the chloro groups are surrounded by electrons. Because of that steric hydrons they bring in, the first ring and the second ring are completely out of planarity, and you find that macrophenamic acid, as compared to the other, because of the two other groups, has actually maximum activity. Then look at mefenamic acid, those two substituents at that position, as I have said, also are responsible for good activity. That's what we're going to see. And again, it has agreed with the general SAR carboxylic group 2. It has 2 aromatic groups, of course, separated by a polar group with retention of activity. So N-anthranilic acids or phenamic acid derivatives are nitrogen isosteres of salicylic acid, quite clear. The nitrogen, the hydrogen replaced with amino group, and there are series of N-substituted anthranilic acids that have since been given the chemical name phenamic acid. Of course, the anthranilic acid on its own will not have activity. It requires a second phenyl group, which is also substituted. These agents are considered to be NRA substituted derivatives of anthranilic acid, which itself is an bioisoster of salicylic acid. These agents retain the acidic properties that are characteristics of this class of agents. However, note that with mefenamic acid and meclofenamic acid, these agents retain the acidic properties that are characteristics of that. However, note that and that point does not make sense. So we are only saying that they retain the acidic nature. Meclofenamic acid and mefenamic acid, of course, they both they do have both. They have a methyl group, of course. The flufenamic acid, the only thing is that it has only one substituent, which is a trifluoromethyl derivative. So mefenamic acid there, meclofenamic acid, as we have said, these two, throwing this molecule completely out of planarity, and it also has the 3 substituent and the 3' substituent, again responsible for very good activity. This other group here is 1, throws, and the hydrogen here. You see, this one will give you much more steric hydrons than the hydrogen. Of course, you have a hydrogen substituent here, but when you have a methyl group, it introduces more steric hydrons, allowing for that group to be thrown out of planarity. When you have 2, then you have more steric hydrons. So we cannot. Mefenamic acid has only one substituent, the 2' methyl, that ensures non-coplanarity. Meclofenamate has 2 such groups, the chlorine atoms, and thus more molecules of meclofenamate assume the correct conformation, and the drug is more potent. Since this class offers no advantage over the salicylates with respect to analgesic and anti-inflammatory actions, there has not been much development in this class, apart from those drugs that we have looked at. So this is the general structure again. And remember, whenever you're given a general structure, you must number. So that when you talk about a substituent at any position, the person who is reading is aware of what position you're talking about. So of course, position number 1, position number 2, like that, and then you come to the amino group, and then where you have that substituent 1', 2, 3', and of course, and so on. So that's the general structure. And we are noting the SAR substitution on the anthranilic acid ring generally reduces activity, whereas substitution of the NRA ring can lead to conflicting results. All we are saying is that you cannot substitute this ring. There's the anthranilic ring up to the amino group. You cannot substitute it. If you do substitution on that ring, a reduction or abolish activity. But this ring you can substitute, and we are saying it brings about conflicting results because for some groups you put them in a certain position, you get maximum activity. For others it is different, but in general the order of activity generally is 3' greater than 2 greater than 4' for mono substitutions, as I have said. And that is why flufenamic acid has its trifluoromethyl group at position 3' for maximum activity. So for mono substituted, you find that 3' greater than 2', much greater than 4'. So you will not get any drug with a substituent at 4' for mono substitution, with 3' trifluoro derivative for flufenamic acid being particularly potent. So it was found, these are found through the analysis, that is through the clinical trials. You substitute a group, you check on its activity, and it was discovered the 3' trifluoromethyl group was responsible for maximum activity, and no other the drug flufenamic acid. But that's why we said there is conflicting results, that the 2' chloro derivative is more potent than the 3' chloro analog. So you can see this is where we are saying there is conflict. 3' trifluoro is more active. Generally 3 greater than 2 greater than, but when you come to chloro, you find that the 2' chloro derivative is more potent than the 3' chloro analog. In disubstituted derivatives, where the nature of the two substituents is the same, the 2' 6' disubstitution appears to be the most effective. And this is very easily explained. 2' 6', it pushes the other ring out of coplanarity, like especially where we are talking about the meclofenamic acid. The most active phenamates have small alkyl or halogen substituents at the 2', 3', or 6' position of the NRL moiety. You cannot fail to specify the NRL moiety. It is not on the anthranilic acid group. Like meclofenamic acid is 25 times more potent than the mefenamic acid. And this is what we have said, because this should be 2,6, not 1, not 2,3. This is what we have said, because when you have a substituent at 2' and 6', the bulkiness of those substituents allows for maximum steric hydrons, and the NRL ring and the other ring and the anthranilic acid ring are completely thrown out of planarity, giving us the best binding molecule, the best bind, or the best highest affinity for the COX enzyme. Hence, this steric effect is proposed to be important in the effective interaction of the phenamates at the inhibitory site. So they are, when you have 2', 6' groups, they introduce higher steric effect, pushing these drugs to be highly non-coplanar, and therefore giving us maximum affinity and binding to the COX enzyme, and hence maximum activity. Of course, the proposed binding sites include the hydrophobic trough, to which the lipophilic group planar with the ring-bearing carboxylic acid function bind. So we are saying, we have already mentioned this. We have two areas. We have the two hydrophobic areas, which we are calling the trough, and we have the carboxylic group, and those are the areas to bind, but there must be non-coplanarity. Substituents of the NRL ring that force this ring to be non-coplanar with the anthranilic acid ring should enhance binding at this site and thus activity. This may account for the enhanced and inflammatory activity of meclofenamic acid, which has two other substituents as compared to meclofenamic acid and flufenamic acid, which have only one ortho. So you can see the meclofenamic acid, the two other substituents for the second ring out of the plane of the anthranilic acid, more than in flufenamic acid, which has no other substituents, and also more than mefenamic acid, which has also one other substituent. Remember, for flufenamic acid, we are putting the trifluoromethyl group at 3', because that is the most active position. But when you have two substituents, you can, if you put them at the other position, then you get the maximum activity. So that is 2 repetition. The NH moiety of anthranilic acid appears to be essential for activity. That is the polar NH group with the joining atom, because replacement of this function with either an oxygen, a methylene, a sulfur, a sulfone, N-methyl, N-acetyl functionalities significantly reduces activity. So we are saying the NH moiety, which joins the two, it joins the anthranilic group and the substituted phenyl group, is important for activity. Its removal or replacement destroys activity. The position rather than the nature of the acidic function is critical for activity. By the position, what we are saying is that the carboxylic group must be ortho. Just as we said for salicylic acid, carboxylic group must be ortho to the amino group for activity. Take it to meta, para, you destroy activity. You can replace the carboxylic group with other groups like the tetrazole, like we had said that when we were looking at the list, with still retention of activity, but you cannot change the position. So we are saying anthranilic acid derivatives are active, whereas the meta and para aminobenzoic acid analogs are not. Anthranilic acid is only when the amino group and the carboxylic group are ortho to each other. That is when you call it anthranilic acid. When it is meta and para, you will name it as a derivative of benzoic acid. So we are saying the position of the carboxylic group relative to the amino group, they must be ortho to each other. Change of that position destroys activity. Replacement of the carboxylic acid function with other, like isosteric tetrazole moiety, has little effect on activity. In other words, you can replace the carboxylic acid with the tetrazole with retention of activity, but you see that tetrazole molecule is so complex. It doesn't give you any benefit, so why bother? So you leave the carboxylic group. We have said that these drugs, the phenamides, the anthranilic acid derivatives, they did not have any added advantage over the carboxylates, over the carboxylic acid derivatives or the salicylates. So with the exception of those three drugs, there was not much development or much more development or much more studies on the phenamide derivatives because they were not found added advantage over the salicylates. Absorption and metabolism, rapidly absorbed following oral administration, again highly bound to plasma proteins. It has a carboxylic acid. Metabolism occurs through regio-selective, meaning it's very selective oxidation of the 3' methyl group and glucuronidation of mefenamic acid and its metabolites. Regio-selective means it's going for the 3' and not the 2'. Regio-selective 3' methyl group and glucuronidation of mefenamic acid and its metabolites, because it has, of course, a carboxylic group. The 3' hydroxymethyl metabolite primarily as a glucuronide or as a dicarboxylic acid. And all we are saying, you see, if you have the 3' hydroxymethyl, this is a CH2OH. It can go further oxidation to carboxylic acid. If it undergoes further oxidation to carboxylic acid, there will be carboxylic acid group at 3'. There will be carboxylic acid at 1 position, and therefore it becomes a carboxylic acid. So that's why we are calling it dicarboxylic acid, and it can be either primary as a glucuronide or as a dicarboxylic acid, of which 30% is a glucuronide conjugate. These metabolites are essentially inactive. So again, oxidation, and we can look at, so we are saying these are mefenamic acid here. So that's position 1, 2, 3', and we are saying regioselective. So this is the group that undergoes oxidation. So it's CH2OH there, and that CH2OH can undergo further oxidation to carboxylic acid. And that's why we are calling it dicarboxylic acid. That carboxylic acid, that carboxylic acid. This might not require to undergo gluconic conjugation. It's already highly water soluble. You can also have this with the alcohol derivative there, and this undergoing gluconic conjugation. You can also have this with this already carboxylic acid and undergoing gluconic conjugation. I want to believe, if you look at the handout, yes, page 15, according to my handout, you will see metabolism of mecrophenamic acid, whereby we are saying you can get the 3' hydroxymethyl derivative, which is actually active, and that you can also get the 4' hydroxy derivative. You can also get the, this was for, and you can also get the 5'. This was not complete. If you look at page 15, it gives you the complete metabolism of mefenamic acid. You can get the 3' hydroxyl derivative, which can then go to the 3' hydroxy and 4', 3' hydroxy. You can also have the 4' hydroxy. You can also get the 5 hydroxy. All those are possible derivatives. And of course, now we add what we have found here. Those groups can also undergo glucuronic conjugation. So you can pick what we have picked here. The groups that we have here, the carboxylic group can undergo glucuronic conjugation. The CH2OH group can undergo also oxidative glucuronic conjugation. And all that we need is that those groups are removed from the body. So from what is on page 15, all we are saying is that this ring here can also undergo hydroxylation at position number 4'. So it's 1, 2, 3, 4. This position here can hydroxylation. One can understand because an amino group is like a hydroxyl group. It's an ortho-para director. The para position is already occupied, but the para position is not. So this position here can undergo oxidative hydroxylation. This group here is ortho, meta, para. Again, so this group here, in reference to this ring, it is a para director also meta. So this position here, position number 5, can also undergo hydroxylation. So that's what you're saying. This position here can undergo oxidative hydroxylation. That position there can undergo oxidative hydroxylation, but that will give us minor metabolites. But that can happen. And once that happens, and then of course there can be the glucuronic conjugation, and in adding the hydroxyl group, adding the glucuronic acid, then the resultant products are highly water soluble and readily removed from the body. So what you can do on the sheets that I have on the printout I've given you, add also the conjugation or conjugates, the glucuronic conjugates that can also be there, so that the metabolism of mefenamic acid is complete. Pharmacokinetics, it is rapidly and almost completely absorbed following oral administration. It's again highly bound plasma proteins, almost all of them because of the carboxylic acid. The metabolism involves oxidation of the methyl group, aromatic hydroxylation. So we have mentioned oxidation, aromatic hydroxylation, and sometimes also monodehalogenation and conjugation. The major metabolite is the product of the 3-methyl oxidation and has been shown to possess anti-inflammatory activity. So 3-hydroxy methyl derivative is a major metabolite, and indeed it's active. If you look at also the printout that is there, and it has been stated that it's active. That, well, the metabolism is just looking at just understanding the groups that are there. Then we have the meclofenamic acid. Again, meclofenamic acid, I don't think I've given you metabolism of meclofenamic acid, but it is here. Meclofenamic acid, now the difference is that, of course, meclofenamic acid has these halogens that decrease the metabolism, so they will not allow for oxidative hydroxylation of almost the whole of these molecules, because they are withdrawing electrons. So meclofenamic acid mainly undergoes this formation of the hydroxymethyl derivative, which can also go to carboxylic acid. Of course, this also can always undergo glucuronic conjugation. This group always can undergo glucuronic conjugation. That group also can undergo glucuronic conjugation. So that is the main metabolism. So we find that the meclofenamic acid, because of the halogens, has a slightly different metabolic pathway, where it is not undergoing oxidative hydroxylation of the phenyl rings, because, as we know, halogens will decrease or inhibit that kind of oxidative aromatic hydroxylation because of electron withdrawal. Again, indication is mainly for pain, fever, and inflammation. Pain, fever, and inflammation. So again, we had drawn those drugs there, so that is nothing new. And with that, we finish the phenamides. Any question?
Jocelyn?
Yeah?
I'd like to take you back. When
Yes.
you're talking about the metabolism,
Yeah.
the structure that the handout that you sent on the page 15, it's showing the metabolism of meclofenamic acid. And in your previous statement, you said that meclofenamic acid cannot undergo hydroxylation because of the chlorine groups that are there. But in the handout, it's showing different.
Yeah, let me just confirm that. Well, this is meclofenamic acid, yeah? I would not expect this. But you can see, like, the hydroxylation, that's 35%. This one, yeah, actually, yeah, I get your point. But the 5-hydroxylation is only 3 to 6%. That's almost negligible, isn't it? The one which is actually a lot, which is the 3'. The 3'. The 3'. In fact, the one which is supposed to undergo that hydroxylation is this one. This meclofenamic acid here is not showing it. Let me find out, yeah? So, because the one I expect to really undergo this kind of hydroxylation in the different positions would be the mefenamic acid. Are we together? Mefenamic acid, but let me find out, because I would expect mefenamic acid to be the one which undergoes oxidative hydroxylation. You see, these halogens, they really decrease the metabolism, especially of this ring, allowing this ring to undergo oxidative hydroxylation is an uphill task. But for mefenamic acid, I would expect. So let me go and find out whether this was supposed to be meclofenamic acid or mefenamic acid, because oxidation of an aromatic ring which has halogens, and it has two. Of course, there is also the other opposing effect of the fact that because of this amino group here is also an orthopara director. And that's why, just as we talked about the salicylic acid, that's why I expect that this drug is the one which would undergo hydroxylation at this point, a lot of it, and also hydroxylation of this ring. This is also an orthopara director, so it will direct ortho-metapara to direct hydroxylation there. It will also ortho-metapara, it will also direct hydroxylation at that point. That's what I expect, but I'll confirm. Let me confirm what is on the handout, whether it's supposed to be meclofenamic acid or mefenamic acid. Thank you for pointing out that, but it will be good for us to. I will confirm that. So, thank you for that. I'll confirm that because I would expect that to happen more for the mefenamic acid. But as I have said, when you look at the halogens, if I look at those halogens too, where was that drug? For the mefenamic acid, the halogens are also meta directors. So if you look at where the halogen is, also meta. So that the 1 5 to 7% is occurring because that 5 to 7%, that position is where the halogen is directing its metabolism and also the amino group at that particular position for the 4 prime. For the 3 prime, 1, 2, 3 prime, 3 prime hydroxymethyl and 4 prime. So that one we have explained. For the 3 prime, for the 5 hydroxymethyl, the 5 hydroxymethyl again is being directed by ortho-metapara. So could be that's why we have those products, because as I had said earlier, again, do remember the halogens as found in the second ring, halogens are meta directors. If any other group is coming in, it will come to the meta position. If you look at the meta position in terms of the halogens, it's ortho meta. It's the meta position will be the 4 prime. And then the amino group on the other ring will direct to the para position, which will be the 5 position. But as I have said, I would expect those metabolites to be very, very low because the halogens also stabilize the rings and to protect or prevent oxidative hydroxylation. Sometimes I will confirm because sometimes the different books we read give us also contradictory information. So thank you for that. I will confirm and be able to tell you next time. Any other question? But for mefenamic acid, the hydroxylation, they're not showing. The hydroxylation, I would expect the hydroxylation in those various positions to really occur. But again, they are not showing those positions. But if you look at the products they are giving us, they are not making 100%. So most probably also those are the metabolites to be found. But in this one, they are concentrating on the ones that are giving us the maximum products. Any other question? This is, you see, like, I think this one had got it from, it should be Foyers. You can see Foyers for metabolic of meclofenamic acid, they are very specific. They are giving this product and that. They are not giving it as a hydroxylated product. So that's what I'm saying. Perhaps sometimes when you look at different books, they can give you different information. So I'll look of meclofenamic acid, and what we had discussed earlier is what I would have expected of mefenamic acid. mefenamic acid, and this one of meclofenamic acid. Wow. Any other question? Well, we were supposed to go up to 11. Can I get your appreciation or any question? Because I think it started 9, 10 up to 11 to not, unless if you want us to go on. Do you have another class? Uko na class ingine? Umenyamaza. Do you have another class? Hadi hamko? Nanisikia? Ya 35. Meenda wapi? Mmekimya kabisa. Students, mko wapi? So sawa, let's sign in that you are there, please, students. Are you okay? Are you happy? Sawa. Umekimya sana. Are you okay? Present. Are you okay? It's good to communicate, even at times to note mistakes, because error is to human. It's important. It shows you are awake. Present. We still have a long way to go. We now have the propionic acids and acetic acids. We have done up to mefenamate, propionic acids, acetic acids, the enolics. Hey, we actually need to meet more than once. There are many. I was willing to meet you this week, plus this week on Wednesday. But it looks like things keep cropping up. I'll see whether I can be able to do it on Wednesday, because we need to meet more than once. That can complete this early. Possible. Is that everybody?